Welcome to Monday. It's January 17th, 2022. Thanks for tuning into the Day Weather Podcast, brought to you by Chugwater Chili, the gourmet spice of Western life. Check out Chugwater Chili Dip and Dressing Mix. It's a southwestern blend of spices, perfect for dipping crackers, vegetables, chips, or anything else you like to dip, or use it as a dry seasoning to season pork, chicken, or vegetables. It's a perfect spice for those who roast and crock pot meals. Get yours today with Chugwater Down, your discount code ChugwaterDon for 20% off. Chugwater Chili, the gourmet spice of Western life. Two cold fronts this week. The week is going to start off very quietly. Very little happening today and Tuesday, but we have a front coming Tuesday night and Wednesday. That will affect areas along and east of the divide, but nothing really west of the divide. It'll be a cool, quiet weekend, but that'll be after another cold front arriving Thursday night and Friday. That one will be a little more moist. That one's going to affect both sides of the divide. It won't be a major storm system, but we've got two little systems to deal with this week. Colder at the end of the month in early February. Right now, what we're seeing is a concentration of the coldest, stormiest winter weather in the central and eastern areas of the United States, as you can tell by just watching the news. We had stormy weather here Christmas week and New Year's week. Simply, it has shifted into the other part of the nation. But what is likely going to happen is a retrograding pattern where the cold air in the central and eastern United States may retrograde back more towards the west. And we'll show you that here in a minute. Also, I want to talk about the Tonga volcano because I always get a lot of questions about volcanoes and do they impact the weather and climate. I have some incredible satellite photos to show you, and we'll talk a little bit about what volcanoes can do to affect long-term and short-term climate trends. First of all, here's today's weather chart. Here's the storm hitting the northeastern United States with heavy snow and winds. Western New York, parts of northwestern Pennsylvania, just getting clobbered with wind and snow, and of course all the ice and snow. You know, it did officially snow in the panhandle of Florida this weekend with that system. But out west, we've got this little upper low that's off the coast of California that'll produce a little bit of shower activity over central and southern California, but northwest flow here that doesn't have much cold air or moisture with it isn't going to do much today or tomorrow. However, notice the dip. Here comes a dip in the jet stream with high pressure building across the west coast, and what will happen is the storm will exit the northeast and a colder shot will come on in along and east of the divide especially. And what that'll do is produce a little bit of upslope. So a little bit of upslope light snow is going to develop Tuesday night and Wednesday along and east of the divide. As you can see right here, that's where the majority of the snow will be. It's not going to be really heavy, but a little bit of upslope, and it is going to be quite a bit colder. On Wednesday, many areas east of the divide will not get out of the 20s, and we'll see some single digits and teens for lows. Then the next wave comes. Here it is. This is a trough coming out of the Pacific Northwest with high pressure building along the west coast a bit more robustly. That turns the jet stream south, and we'll have another shot of colder weather. There'll be a bit more in the way of Pacific moisture with this second front. Again, it's not going to be a big snow producer, but you can see both sides of the divide get a little bit of snow, not a lot, but a little bit of it, along with another wave of colder temperatures. So two little systems this week, nothing major. Now, long term, going out to 10 days from now, this is to around the 26th and 27th of January. As long as this high pressure ridge stays off the west coast instead of just on it, well, then you can see the jet stream is taking a dip further west into the western United States. Well, really most of the nation from the Rockies eastward. So this opens the door to Canada. When you open the door, nothing to stop it. That cold air is going to penetrate, and we're going to see a colder weather pattern evolving across most of the nation by the middle to the end of next week. And if we were to go out 15 days, notice where the ridge axis is. It is further west. It is more towards the Aleutians. And with it more further west, that means the colder air has more access to the western United States, while a warmer weather moves into the eastern part of the United States. You know, this happens during the course of winter seasons all the time. The Arctic air will get pushed east, then it'll kind of wobble, go west, and we kind of have this seesaw back and forth weather pattern. But right at the end of January into early February, is probably the central and western United States' turn to get back into colder and stormy weather again. And we'll monitor this for you here in the coming days. Now let's talk about the Tonga volcano. Now, where the heck is the Tonga area? Well, it's east of Australia. Here's the equator. So it's just south of the equator. This is a classic low latitude volcanic eruption. Now, why is that important? Well, volcanic eruptions that can get higher than 50,000 feet or basically into the stratosphere, when the volcanic ash and the sulfur dioxide and other gases from these volcanic eruptions go into the lower latitudes, when the volcanoes are at a lower latitude, it is easier for the volcanic ash, sulfur dioxide, and other gases to go into the stratosphere. And when those gases and ash go into the stratosphere, it takes a long time for Mother Nature to work out that ash and the gases. And so what will happen is the lower stratosphere gets this layer of gas and a layer of volcanic dust that ultimately, over time, can impact weather conditions and climate. It can be a big wild card. It can completely upset the apple cart in terms of overall large-scale patterns. Now, it has been measured that this Tonga volcano did reach the stratosphere. So there is a lot of ash and gas going into the lower stratosphere. What I want to do now is show you a high-resolution satellite photo from the Japanese Meteorological Agency that monitors this part of the Pacific Ocean east of Australia. What I'm going to do is going to step through several images taken about 10 minutes apart Friday night into Saturday morning. It was local time for the Rockies and the Central Time Zones and the Western Time Zones. This happened overnight Friday into the early morning hours of Saturday. So you can see the beginning of the explosion right here. Then, as you step through time, just an amazing high-resolution photo of how big and how powerful this volcano was. One thing I want to highlight for you, because I'm going to talk about this here in a minute. Here you see the ash cloud, but along the edges, a shock wave is forming. Just like a shock wave you're going to get when you drop a bomb or explode a piece of dynamite. This shock wave grows and expands and was so powerful that the shock wave went basically around the globe, not only helping to form the tsunami, but also, was observed, the noise was observed 500 miles away. Now, as this shock wave went across the western United States during the early morning hours of Saturday, a lot of barometric pressures changed. Now, if you've got a home weather station and you're recording or you have the ability to data log your weather data information, you should really look at the time frame, local time, Rocky Mountain time, right around 5:30 to 6:30 in the morning. What I'm showing you is a barometric pressure tendency trend, basically measuring the barometric pressure over time. And this is right along and near just east of the Continental Divide. This is actually a weather station up in the Snowy Range. You see this spike in air pressure right here? This spike in air pressure is the actual shock wave as it came through the Snowy Range Mountains around 6 a.m. local time Saturday morning. Now, folks took a look at weather station data and saw the shock wave go all the way across the United States and Canada. However, the Rocky Mountains did dampen the shock wave. As the shock wave hit the Rockies, it sort of slowed it down and weakened it. But as it came over the divide, you can see this pressure spike. This is quite humbling to think that something multiple thousand miles away could send a shock wave that could get all the way here and be measured by just a typical weather station. So if you've got a weather station and you're watching or have the ability to graph your data, you may want to do it. Now, how do volcanic eruptions possibly impact the climate? Well, we know we do. In fact, Mount Pinatubo that blew in the Philippines in the early 1990s had a longer than 12-month impact, as it was so big, it got up into the lower stratosphere, produced a lot of gas and dust in the lower stratosphere, and actually there was a real measured cooling due to that volcanic eruption. Where volcanoes blow and when they blow is really, really critical on how the volcanoes may impact the weather and climate. There are numerous scientific studies out there on what volcanic eruptions may or may not do in terms of affecting the climate. If you read the literature, what you find out is that definitely large volcanic eruptions that reach the stratosphere have impacts, and locally, regionally, and perhaps globally, depending on the magnitude and the latitude of where the volcanoes go off. Also, volcanic eruptions can impact the La Nina and El Nino cycles. Also, volcanic eruptions may cause cooling in some parts of the globe and warming in others. But one thing you do find when you read the literature is that there's a lot we don't know about volcanic eruptions and the impact on climate regionally, locally, and across the globe. There needs to be a lot more studies. Here's a little secret for you. We don't know everything. Certainly we don't know everything about volcanic eruptions, so there needs to be more study. But we do know that large volcanic eruptions, if intense enough and long enough, and they reach the higher reaches of the troposphere and lower stratosphere, is they do disrupt things. And it can really have a big impact on long-range forecasts. So we'll see what happens with this Tonga volcano and see if there's more down the road, more volcanic eruptions as we go into the coming months and years ahead. Thanks for tuning into the Day Weather Podcast. We'll talk to you on Tuesday.